We will start with the next problem now. So in this case now, we'll take a continuous beam which is simply supported at A, B and C. On span AB there is a UDL of 20 kilonewton per meter, and on BC there is a point load at center, that is 40 kilonewton. This span is 6 meter, this is 2 meter and 2 meter. So we have to draw the shear force diagram and bending moment diagram. That means we have to analyze the beam. So first P1, a continuous beam, W1 20 kilonewton per meter, P1 40 kilonewton, L1 is 6 meter, L2 is 4 meter. So to find, so what we have to find? So we have to draw the shear force diagram and bending moment diagram. So to draw the bending moment diagram, first we will draw free bending moment diagram. Then we will draw the fixed bending moment diagram. And finally, the net bending moment diagram. So for drawing the free bending moment diagram, between A and B there is UDL. So the shape will be parabola. Here there is a point load, hence the shape will be triangle. So now the next point is to find out what are the heights of this parabola and triangle respectively. So we'll mark here point D and this is point E. In free bending moment diagram, moment at point D is equal to, the formula is UDL, that's why WL square by 8. So 20 into 6 square by 8. Similarly, moment at point E, point load at the center, so PL by 4. So 40 into 4 by 4. So this will be 40 kilonewton meter, and the value of MD is, after calculating, 90 kilonewton meter. So this is 90 and this is 40, this height. Okay, so same now using Clapeyron's theorem. So Clapeyron's theorem is MA into L1 plus 2MB into L1 plus L2 plus MC into L2 minus 6A1 x1 bar by L1 plus 6A2 x2 bar by L2. So we'll find out individually now all the values here. So MA is 0 as simply supported, L1 is 6, L2 is 4 and MC is 0. About A1, that is area of the first diagram here. So this is parabola, so 2 by 3 times of AB. So 2 by 3 times of 90 into 6, and A2 is triangle, so triangle formula half into base into height, so half into 4 into 40. So the A1 value is 360 and A2 value is 80. Now next comes the most important part, that is x1 bar and x2 bar calculation. So x1 bar is the distance of the first centroid from A1. So this is x1 bar and this is x2 bar. So x1 bar from the diagram, this is 3 and x2 bar is 2. So x1 bar, okay, we have not found out the values of A1 and A2 here. We'll write it once again. So this is half into 4 into 40. So this value is 360 here and this is 80. Now x1 bar is 3 and x2 bar is 2. Now substituting all values in equation A. So this is our equation A. So we'll get 0 into 6 plus 2 MB into 6 plus 4 plus 0 into 4 is equal to minus 6 into 360 into 3 by 6 plus 6 into 80 into 2 by 4. So upon calculation you should get it as 20 MB is equal to minus 1320. So MB is equal to minus 66 kilonewton meter. So this minus sign indicates the hogging nature. So we can also write it 66 kilonewton in bracket hogging. Okay. So there is some problem, I think. So this is getting erased. Okay. So now we have calculated both MB. Now we'll draw here. So this is MA, this is MC, and this is MB. And the value of MC is 66. Okay. So this is 66 here. Now how to draw the net bending moment diagram? Combining the free and fixed bending moment diagram. So free bending moment diagram, this is 90, then this is 40, and overlapping it with the fixed bending moment diagram. So this is 66. Now here this is all positive and this is negative. Point F and G are point of contraflexures. So now we have got the value of MB. Now we will draw the shear force diagram. So for drawing the shear force diagram, we will have to consider first the original beam. This is subjected to UDL of 20. Here point load 40. The reaction at this point A, B and C, this will note at VA, VB and VC. So MA value is 0, MB value is 66 and MC value is 0. So we'll consider AB first. So consider AB. So this is VA 26 and there is a moment here at B, that is 66. Now what you will do is you have to apply the condition of equilibrium here. And what is the condition of equilibrium? We have to apply here. We have to apply only sigma MB is equal to 0. There are many methods to find out the VA, but this method which I am telling you here, I think this is the most easiest one. If you practice it 1 or 2 times, it will be very much easy. So sigma MB is equal to 0 will apply and we'll take the clockwise moment as positive. So we'll get VA into 6 minus 20 into 6 into 3 plus 66 is equal to 0. Upon calculation, VA is equal to 49 kilonewton. So we have got the VA value. Similarly, now we'll consider BC. So this is B, this is C. There is a reaction here VC, point load of 40 and a moment of 66. 2 and 2. Same thing, apply sigma MB is equal to 0 and clockwise positive. So it will be minus VC into 4 plus 40 into 2 minus 66 is equal to 0. So upon calculation, VC is coming as 3.5 kilonewton. Now the last step is to consider the entire beam ABC and apply sigma Fy is equal to 0. That means all the vertical forces is equal to sum of all the vertical forces is equal to sum of all the vertically downward forces. So here it will be VA plus VB plus VC, and this is equal to 20 into 6 plus 40. So VA is 49, VB we have to find out, VC is 3.5 is equal to 120 plus 40. Upon calculation, VB is equal to 107.5 kilonewton. So now we have found out all the values here. VA is 49, VB is 107.5 and VC is 3.5. Okay, so while recording, some of the pages are not saved. So when you are watching this video, you pause it and keep writing whatever I am telling you, okay? Because at the end of video, you may not be able to see this calculation here, okay? But before we have done this calculation. So now for drawing the shear force diagram, so this is the zero line. At point A, 49 upwards. So this is 49. Then UDL is there. So 49 minus 20 into 6. 49 minus 20 into 6 will give the answer 71. So that 71 will be minus 71 here. Okay, negative sign. Now minus 71 plus this upward reaction 107.5. So you do the calculation, minus 71 plus 107.5. This will come as 36.5 plus 36.5. This plus 36.5 is positive. So it will come here plus 36.5. Now between this point C and point E, between this point B and point E, there is no load present. Hence the shear force will be constant up to here. Now do the calculation, 36.5 minus 40. 36.5 minus 40. This will be minus 3.5. So minus 3.5 it will come here. Similarly between E and C there is no loading. Hence it will be constant up to C. And this is 3.5. Now this minus 3.5 and VC, what is the value of VC? This is also 3.5. So perfectly it will balance. All the values above yellow line, that is zero line, are positive and below are negative. And this is our shear force diagram. Practice this 2 to 3 times. Practice the previous problem also. Then it will be very easy to draw the shear force diagram. The main part is to calculate first the shear forces here, VA, VB and VC. And how to find out? First consider AB, then consider BC and then consider ABC. Whatever the movements you are getting in the second step using Clapeyron's theorem, you mark it here on the beam as it is shown here, this 66 and 66, and then accordingly you apply the procedure. So this is how you have to draw the bending moment diagram and shear force diagram of the continuous beam.